Okay, so I'll be sharing my screen now, and I hope you can all see my screen, and we start. So please, can everybody see my screen? You can always text in chat box if you don't want to unmute your mic. So can you see my screen now? Okay, so I guess so. Today we'll be looking at statistics, and be taking two sections. This today's section and the next section is going to be on Thursday, and we're going to be looking at some very very important things. We have six sections for this course, and I'll be taking the first two, and I would tell us to be available for the rest of it because we're going to be learning a lot. And yeah, statistics, introduction to statistics. When we talk about statistics, what are we trying to say? And what is statistics? So we say statistics is the science of collecting, analyzing, interpreting, and presenting data to help us understand patterns, make decisions, and draw meaningful conclusions about the world around us. And please, I hope I you can see my screen, and I hope I am very audible. You can always put it in the chat box if you don't want to unmute your mic, and please let me know. So statistics. What is statistics? Again, we say statistics is the science of collecting, analyzing, interpreting, and presenting data to help us understand patterns, make decisions, and draw meaningful conclusions about the world around us. I'm sure some people, like, most of us would have just seen this definition, like it looks similar to you defining data analysis. Yeah, most times as a data analyst you must, yeah, understand what statistics is all about. And to break it down, I said in a simpler term, statistics is like a toolbox that help us make sense of numbers and information. It allows us to take large amount of data and turn them into useful insights that can guide our choices and help us better understand various aspects of life, from business and science to everyday um, decision everyday decision. So when we're saying statistics, we are literally just trying to talk about, okay, when you have access to a very large data, you want to make sense about from something that is not making sense. You are, sometimes when you get access to real data, or and you are raw data, and you're like, okay, what can I do with this? Statistics gives us that toolbox, like we said, to help us make sense from the numbers and whatever data we have access to. So sometimes, it's like saying that, we are trying to analyze data. So when we get this data, just like I said, science of collecting, analyzing, interpreting, and presenting data to help us understand patterns. So now when we have access to, like, you know do some things that we feel like we're not understanding in terms of, getting this particular data. So when we get this data, statistics help us and aids us to actually, analyze this thing, interpret it. And aside that, there are actually examples of, how statistics come in to help us understand what we want to do with the particular information we have. So you can talk about statistics as how, someone is likely to purchase a product. Are people likely to purchase this if they can use a different payment method? So, like, it helps you to, find sense out of something that is like looking like nonsense. So just as I've said, it allows us to take large amount of data, turn them into useful insights that can guide our choices and help us better understand various aspects of life, from business and science to everyday decision. So what is statistics used for? What is statistics used for? So statistics is used in all kind of science and business application. So it gives us more accurate knowledge, which help us make better decisions. Statistics can,
Hello, Sal.
yeah, I can hear you.
Can you hear us? You are muted, oh.
Yay.
Hello?
Wow. So sorry about that. I did not know. I did not know. So sorry about that. Okay.
Need to start from the scratch, oh, because we
Yes.
didn't hear anything.
Yeah, no problem. No problem. Sorry about that. Okay, so can you see my screen now? Can you hear me?
Clearly, sir, we can hear you now.
Okay, sorry, so sorry about that. So, as I said, I started with statistics, like I said, introduction to statistics. So, when we're talking about statistics, what do we mean by statistics? So, what is statistics? So, statistics is the science of collecting, analyzing, interpreting, and presenting data to help us understand patterns, make decisions, and draw meaningful conclusions about the world around us. So, in a simpler term, we say statistics is like a toolbox that help us make sense of numbers and information. It allows us to make large amount of data and turn them into useful insights. And turn them into useful insights. So, sorry, let me admit this person. Okay, and turn them into useful insights that can guide our choices and help us better understand various aspects of life from business and science to everyday life. So I was saying that statistics is just a way of helping us get information. So for example, we have access to data that we don't know what to do with it, we don't know how to get sense from it. But statistics is that science that would help us aid how we would collect that data, analyze it, interpret it, and present it in order for us to understand patterns, make decisions. Also, I was giving examples like, for example, you have, a store trying to get how they can likely see someone to how people can get to purchase their products. Statistics will help us, find a way we can do that. And aside that, um, it also actually help us to see the likely payment method people would use to purchase things. So due to statistics, we can easily find a way to say, oh, okay, what if this is this? What if we try this? Okay, we have access to this data. What if we try to perform some descriptive or inferential statistics on them to make sense and get some informations from it. Sorry, let me meet this person. Okay. So, what is statistics used for? What is it used for? It says statistics is used in all kinds of science and business applications. Statistics gives us more accurate knowledge, which help us to make better decisions. It can focus on making predictions about what will happen in the future. It can also focus on explaining how different things are connected. How different things are connected. So sometimes I think when we were talking about in the Power BI class, I could remember, so we're trying to see how we can, you know, take a survey and see how much we can understand a people. So, for example, we have a store somewhere that's trying to come into a particular location. So maybe they have to feel like, okay, what if we try do a very very good survey about how we want to make sales in this environment because the location looks quite new. So they did their survey and they called an analyst and the analyst was like, what if we try to see how we can use the income of each individual in this location to determine how much you would get to sell from the particular business you're trying to start here, And while the the data analyst took that project, he had to be like, okay, I'll just take a survey, and by the time he took a survey, it was as if like it was trying okay the data analyst was trying to get the average amount of average salary that each individual collects every month, each household in that location. So why he did that, at a point he got a particular figure, or he got to you know did all the analysis and all, and a particular figure was gotten. But on the long run, when the business started, it wasn't looking as expected. So probably in a particular rural location, somebody tries to open a store to sell washing machine and the rest, and for like 6 months, he has only had 2 to 3 sales that are quite big, and most of those people are not even coming from that location. They are coming from outside based on referral from some people he has sold to in a different location. So it's not like, okay, what's wrong? What's going on? Then he went back to the analyst and like, I don't understand. How did you make this analysis? And with all the analysis you made, you were giving me a green light that like we start here, and suddenly sales is not coming. So then the data analyst had to go back to the analysis he did and all. Then he got to find out that while he was doing the analysis, he didn't take note of outliers, whereas some people were literally earning like just like 3 to 4 people were actually earning much more than than the average individual in that place. But because the outliers were not detected, it was able to influence the results that was gotten from the analysis made. So how do we get to do about these things? Statistics help us make sure we get to understand how we would go about getting the data. While getting that data, we explore that data. While we explore that data, we need to do what? We need to prepare it. When preparing it, we need to say, okay, what's next for me to do? Analyze this thing before I get insight. So well, at a point, when you use there are some particular models we use in terms of regression analysis, whereas you're trying to see find the difference and relationship between some dependent and independent variables. It can help you know that, oh, this thing is all about this is what will happen, this and this will happen. So statistics gives us more accurate knowledge, which help us to make what better decisions. Statistics can focus on making predictions about what will happen in the future. It can also focus on explaining how different things are connected. Moving on, let me see if let me admit the person trying to join. Okay, none for now. So typical step of statistical methods. When we talk about typical step of statistical method, we're talking about the typical steps of how we, go about statistics, the method. If you could see from the diagram I have here, I have statistical inquiries cycle, where we talk about the problem, the plans, data, analysis, and collection. So, but the typical aspect, I put it all together into three phases, saying gathering the data, describing and visualizing data, and what? Making conclusions. Now, before you get to gather the data, from the diagram here, we talk about the problems. Define the problem and investigate questions. So you defining that problem, would be able to give you that way of thinking critically to know the kind of question you'd ask. To know the kind of question you'd ask. So for example, I'm trying to start an ice cream business. Trying to start an ice cream business somewhere, and I'm like, okay, I'm not going to be going around. I just want to have a shop. Sometimes I need to consider the location I'm going to start that business. What if I start somewhere that they are not, they don't even want to say anything ice cream. But then, what if I start close to a school? What if I just open a small container somewhere and I'm like opposite the school or beside the school? Whereas I know that obviously students will want to like take ice cream. That way, it has given me an edge to know that, oh, I will be able to like start well and try to expand. So if me as a data analyst is consulted to come and do these findings about me trying to understand where an ice cream seller can start a shop. I'll start considering, okay, what kind of ice cream do you want to sell? Do you want to sell expensive ones or cheap? Is it going to be in a container? Is it going to be sealed with nylon? Questions like this would now help me understand, oh, these are the kind of location you should go to, that kind of thing. So statistics inquiry cycle is just, defining that problem. And when you define the problem, you investigate question, you plan what to measure, study designs, the variables. The next thing is what? Get data. So you collect and clean, analyze, explore using graphs and summary statistics. Think hard, relate to context, and conclusion. Answer the question and may lead to other question. Communicate. So it is important for us to keep all three steps in mind for any question we want more knowledge about. So knowing which type of data type are available can tell you what kind of question you can answer with statistical method. Knowing which question you want to answer can help you guide what sort of data you need. A lot of data might be available, and knowing what to focus on is very, very important. That's just what statistical method help us do, because when your question is not quite very defined, and you don't even understand the problem. How do you want to get access to the right data for you to use? So in this way, statistics help us to understand that we need to know how we get to find data. When we find the data, what type of data do we have inside the data? Do we even know each column's data type? Do we know um, how we can, answer the question with the kind of data we have? And do we know what we are really, really focusing on? So sometimes you need to take these typical steps of statistical method, which is all about you gathering that data, describing and visualizing data, and making conclusions. Moving on to the next, how is statistics used? How is statistics used? I hope my screen is showing and you can all hear me. So, moving on, statistics can be used to explain things in.
Yes, sir, but can you be a little more audible,
Okay,
please, sir?
okay, okay. So, statistics can be used to explain things in a precise way. You can use it to understand and make conclusion about the group that you want to know more about. The group is called population. We're going to an interesting part. The group is called population. So, population could be many kinds of group. So I'll start again. Statistics can be used to explain things in a precise way. You can use it to understand and make conclusions about the group that you want to know more about. And this group is called a population. And when we're talking about a population, what do we mean by a population? What are we trying to talk about? You're just saying that a population is just more like, a whole part of a particular place. Whereas, you're saying in terms of this group we're talking about, which is population, saying the population, all the people in a particular country, all the businesses in an industry, all the customer of a business, all the people who play football, who are older than 45, at that moment, they are a population of, they are one group, and so on. So it just depends on what you want to know, actually. So sometimes you need to, get to know what you are trying to focus on. What are you trying to focus on? What is the when you understand the business, you know that okay, this when you understand the problem, you know that this is what you want to focus on. You know that this is what you need to find for. You need to make research for, because sometimes you need to make research in a way that you need to find how you can get the information you need to answer the problem you are facing. So gathering data about population will give you a sample, and this is a part of the whole population. Statistical method are used on that sample. Now, when we talk about samples and population, actually in real world that we have now, most of the time we don't get access to the whole population we need to do so. If we're trying to, do a survey, or we're trying to do something in using statistics, we don't get access to the whole population. Actually, most of the time we get access to samples, whereas the sample is not what we use to make the conclusion. So even here, I said the result of a statistical method from the sample is used to make conclusion about the population. So most times when we try to do something, even if it's a country thing, we don't have access to get the whole country kind of information to do what we want to do, but rather we go for what a sample. So that's why you're saying they're talking about okay, all the people in a country. So for example, if I want to perform a particular analysis in a particular company and I'm to focus on a particular group, I can say okay, let me make a sample of you know, a random sample. Whereas I just say, okay, I can remember there are sometimes when we're trying to play some games, the right numbers into papers, and they just tell everybody to pick individually. That's an example of a random sampling. When you just come pick paper, so you don't even know the number you're going to be picking because it's random. So if I want to do a particular sample about a particular about a particular industry, a particular company, whereas I'm to get the feedback of some particular employees, or maybe I have to do it all over the world, where we have a particular industry that you can find them all over the world. I might not be able to access all of them all over the world, but the ones I have access to, which are quite close to me, try to touch each of the departments, and with that, I'll be able to get what I need to um, solve the problem I am to solve. Sorry, let me check in this person. Okay, so that's just it. Like I said, the result of a statistical method from the sample is used to make conclusion about the population. Type of data, data types in statistics. It's quite very important to understand these things because sometimes when your data is not in its correct type, you might not be able to give or answer the particular problem you're trying to. Even sometimes you might get errors actually because if the data type is not correct, you're not able to work with it. So in this class, we'll be learning about those data types and what are these type of data types we're talking about. Talking about the qualitative and quantitative, and we're also talking about measurable scales when we talk about nominal, ordinals, intervals, and ratio. Talk about discrete and continuous data. Discrete and continuous data. Discrete and continuous data. So if you see from the diagram I have here, we're going to be touching all this, but you can see we were able to split them out into how they work. So when you talk about this type of data, we're having the categorical data, and this categorical data is known as the qualitative. And when we hear about category, obviously we're talking about putting them into categories, into steps, into stages, stuff like that. And when we're talking about discrete or continuous, we're talking about quantitative. When you talk about quantitative, we're talking more about numbers, where we talk about ways mathematical aspects can be applied to this part of these data. And the category type is just used to describe, yeah, that word describe. So for example, I have a particular bag or I have a particular box in which it contains balls. So for me to know the kind of the number of balls there, yes, I will just count. I'm like, okay, I have 10 balls in this bag or I have 10 balls in this box. But then how do I know the kind of balls that are there? Oh, blue balls, red balls, green balls. Now, from these balls, it's easy for me to now say from the from what I just said now, it's easy for me to say, oh, I talk about the quantitative, telling me this is the number of balls that are there. Now, categorically, I'm talking about what kind of balls that we have it based on color, which are talking about the blue balls, red balls, or green balls. So let's talk about qualitative and quantitative data. So when you talk about a qualitative data, it describes qualities or characteristics. Describe qualities or characteristics. So they are non-numerical informations. The non-numerical informations. Let me try and relate these aspects to. I'm sure some of us have, we attended the Power BI class where you talk about, facts and dimension table. Where we talk about facts table is more the ones that have the values, and we talk about dimension tables are the ones that are like, try to describe. Whereas, we could say, okay, we have so money, and and this is the amount we are making from a particular product. The product itself will be talking about, would give a description to the value. So when I'm saying in a particular um, shop, we have sales from more from the electronic gadgets. Then the electronic gadgets and all those stuffs like that. We're talking about the qualitative itself because they are describing. They're going to describe and tell us the amount we're making from that aspect of this sales in shops. So when you talk about qualitative data, you're saying when you have, when you want to describe qualities or you want to describe characteristics, that non-numerical informations. So examples, we're talking about colors, we talk about emotions, we talk about opinions. So these things are the key point is they categorize or describe attributes. They categorize or describe attributes. So when you categorize, you're saying just like the example I gave in terms of the balls, I said the red, the green, the blue. So that is me categorizing this thing in terms of color. In terms of color. But when you are saying describe, now I have a particular you know value, and for me to get wider values there, I have to have something that will be describing it. So literally qualitative data is what help us get a description about a particular variable value of variable I have. So when we talk about quantitative this time, let's move to quantitative. When we talk about quantitative data, this represents quantities or amounts. It represents quantities or amounts. I'm sure, let me try and take us back to that time when we know there's this way where we are doing if we can remember in chemistry when we talk about qualitative and quantitative analysis, where we at one time when you're trying to do um um the combinations of some particular chemicals to form new ones. Then you start looking for residues and the rest. Then when we now get to the quantitative, if you can remember, you start doing something like titration and stuff. You get the values. This is what you did, first titer, second, stuff like that. So these things are things that are literally around us. They're literally around us, and we see them every day. But getting to understand them and know them as we see them, it gives us a very big edge as analysts to be able to like get a data and know that, oh, these ones are not values that need to be numerical. These ones are value that needs to be in form of text. These ones are value that need to be in forms of etc. So when we talk about quantitative data, we're talking about numerical information. And examples are what? Height, temperature, income. And what is the key point? It can be measured and mathematically analyzed. It can be measured and mathematically analyzed. So, for example, I was told to find the amount of employees we have in a particular company. So I can just tell them, oh, we have just 30 in the company. Okay, 30. Uh-huh. It's not complete because you just gave me the quantity. What if I want to know about the quality? Oh, yeah, you tell them, okay, we have 15 males, 15 female. Now it makes sense. That's why qualitative and quantitative data, the gas, they have to be, together. They work hand in hand like that. So one can be measured and mathematically analyzed, while one, is in terms of category or describes attributes. Now, moving on, measurement scale. Let me move backward. If you can see, we're talking about qualitative and quantitative. Now, these measurement skills now fall under the two I just finished talking about now, which is also, nominal, ordinal, interval, scaled, ratio, interval scaled, ratio scaled. Now, measurement scale. Now, we'll talk about a nominal scale. This, categorize data without any order. We're not trying to put it in terms of order. It does not count. So if you're talking about eye color, saying blue, brown, green, no numerical value, yeah, nominal, but this one there's no numerical value or ranking. So it's just there, where we have access for since it's going to categorize that data, but the thing is it's not in order. It's not in order. So that's that about nominal. We'll talk about ordinal. Ordinal scale is talking about categorize and order the data, but doesn't show the degree or difference. It doesn't show the degree or difference. So what are we talking about? So we look at education levels. We categorize them, say, oh, you do high school, you do bachelor's degree, you do master's degree. At this point, we have been able to do what? Categorize it, even if it is, and as we have categorized it, we have been able to put it in what? In order. So sometimes we need to get to understand that there's a difference between nominal and ordinal. In terms of ordinal too, there are some things we see while they send survey, and when they send the survey to us, you would feel like, why are they asking this question? An example of an ordinal skill still has to do with that of, okay, for example, we're trying to send you some amount of money for the month. Please pick any of these options to let us know whether you are cool with it. And in the option you're seeing, strongly disagree, somewhat disagree, neither agree nor disagree, somewhat agree, strongly agree. These are what we talk about. These are what we mean by ordinal skills. So these ways they show order, but the what? But in the key point, he said it shows orders, but intervals are not consistent. The intervals are not consistent. So it's very, very important for us to understand what we mean by nominal skills and what we mean by um, ordinal skills. Now, interval skills. This is when you have others data with consistent interval, but no true 0 point. So, for example, you have temperatures in Celsius or in Fahrenheit, and the key point is you can add them and you can subtract them, but cannot multiply or divide meaningfully. You cannot subtract or divide meaningfully. Also, we have ratio scale. And when you talk about ratio scale, he said these are others data with consistent intervals and a true 0 point. Example, height, weight, income, and so on. So if you look at this now, these things, they fall under The interval and the ratio fall under what? Quantitative. The nominal and the ordinal fall under what? Qualitative. As you can see, we can perform mathematical operations on them, you know, from that of the intervals and this ratio scale. So now it's talking about terms of how these values are, and how they can be ordered in consistent interval, and what some have a true 0 point, and you know some don't have a true 0 point. So it's quite good for us to know the difference between these kind of skills. So when we get to see them in our data set, it's easy for us to say, oh, okay, this is what this means, this is what this is all about. So this is how I can work with it. Now, with this, I'm sure we've been able to get why we have nominal, ordinal, interval, and ratio. But like I said, they fall under what I just spoke about, which is the quantitative and qualitative. And when we talk about quantitative, we have discrete and um, continuous. Now, under this discrete and continuous is where we have the interval skills and ratio skills. Now, moving on, discrete data and continuous data. Discrete data and continuous data. So, when we talk about discrete data, these are data that can only take specific countable values. Specific countable values. So, for example, we have number of students in the class, the shoe size, even ages. Okay, how old are you? I can't tell you I'm 38.5. No, I want it's going to be whole number. It's going to be whole number. So when we talk about discrete data, a type of data that are what they take specific countable values. And examples that we're talking about the number of students in the class, the shoe size. So key point, usually they are usually whole numbers and cannot be divided into smaller units. They cannot be divided into smaller units. Now, when we talk about continuous data, what do we mean by continuous data? These are data that can take any value within a range. So we have height, we have time, we have temperatures. And when we say this, we're talking about all those values that you see that have, in terms of decimal points, 38 point this time, this over this point, this like that. And what's the key point there? They can be divided into smaller and smaller units. Smaller and smaller units. So you can have somebody with, you know, ages of okay, the height information of okay, this time point, this smaller one, this point, this. But when we talk about discrete, we're saying whole numbers. We're saying whole numbers. Moving on, data collection. Data collection. What do we mean by data collection? So we're saying that data collection is the process of gathering and measuring information on variables of interest systematically. The process of gathering and measuring information on variables of interest systematically. So if you could remember, I was giving some examples about how I get to want to like get a particular data or a particular location because I'm having a store that wants to come into that particular location. So from this chart here, I wrote some. We have some data collection methods where we have forms and questionnaires. So you see, sometimes when some people just send in some, you know, um, forms for will kindly fill in this survey for me. This. Some people that come in person, they just say, could you help me fill this? Could you help me do this? These are ways for them to gather this data. Another thing is interview. Yes, a lot of people go to do interviews to people, and that way they are literally getting data because you know based on whatever they are trying to address, they feel that the best way they can get their data to answer their questions. So we can get data through observations, we can get data through documents and records, we can get data focus group, oral history, combination research, online tracking, online marketing analytics, social media monitoring. So, what's the purpose? The purpose of collecting data is to answer research questions, test hypotheses, and evaluate outcomes. Because if we don't get to collect this data, how do we get to answer research questions? How do we get to answer research questions? So, for example, some people have been trying to like know the average score of students while they do jam in Nigeria, and you know before they know, they have to pay me for the past 10 years. Before they go online, they try to get data because either they go to jam to try to see if they can get access to their data, or their anyway they can get access to those data. And when they get the access to data, they try to see how they can pull out the information they want to pull from that data. And before you know, they're giving us outcomes. And from there we can get to understand that, oh, truly, for the past 10 years we've been having students getting to read well for their exams and getting to pass well. And or to say, for the past 10 years, the rate at which the scores of jam students has reduced is crazy. So key points: ensure integrity of the research. It's very, very important. Very, very important. You have to ensure the integrity of the research. Number two, forms the foundation for data analysis. Yes, data collection. I'm sure while they were teaching us, from the scratch or from the Excel and Power BI classes, they talked about data analysis process where you have to ask questions. While you ask questions, they get data from data sources. While you do that, you explore the data. While you explore the data, you prepare the data. When you prepare the data, you analyze the data. When you analyze the data, you give insight. So data collections form the foundation for data analysis, and it's also critical for making informed decision. Because when you've gotten a very good data, you've been able to the focus you want to look into. It will be easy for you to make informed decision. And from there you can say, okay, what if this and this? So for example, you got called by an ice cream. Sorry, I'm just saying ice cream. I love ice cream. So you got called by an ice cream shop owner and like, oh, I don't know what's going on. Sales has not been coming this particular. I don't know. This period is just so weak and so bad. What can you do to for us, analysts? I'm like, okay, okay. Let me just ask some questions. Just citing an example here. When did you start experiencing this? Do you think students are on holiday? Uh, do you think probably because it's rainy season, or do you think probably because so many questions I have to start trying to ask, because I need to know why he's not having good sales, and it's my responsibility to help him find out answers. And how do I want to do that? Okay, I want to make I want to get that from data. How do I get to do that? Probably I get to get data from them that they've had or they've collected, or try to send surveys to the people that they sell to, or try gather data by saying, okay, what if you give these forms and questionnaires to these people, or you try to interview some people. And then while collecting this data now, you need to make sure you are not biased, which you are going to be looking into. So it is very, very important to ensure integrity of the research. Moving on, basic sampling techniques. Basic sampling techniques. Sorry. Okay. Our call is going to end in 15 minutes. Okay, no problem. Uh, I feel we should finish before that time, and if not, I would create another um, link. So we'll talk about basic sampling techniques now. If you could remember, when we talk about population, you're saying that most of the time, we don't have access to the whole population. But then sampling, getting access to samples help us, do what we want to do and help us get answers to what we want to do. So for example, we have some basic sampling techniques. We talk about sample random, sample random sampling. Every member of a population has an equal chance of being selected. I give an example saying, for example, when you write numbers into papers and you cut them and you fold them and you just drop and you say, okay, everybody come and pick this number randomly. So you're trying to, use random number to generate or to select some particular people. Okay, we want people that want to go and represent us in this quiz. You just call some very good good individuals are doing these things, and you're like, these people are too good, I can't pick them. Let's look partial. Okay, take numbers, and you want the 1 to 4 or 1 to 5 people of them, and you call 10 of them and you just drop and you put those 10 numbers. And by you do that, anybody who picks the 1 to 5, oh, you come here. So that way you're not being partial, because it is not your fault that this one is picking 1 or 2, but you know that all of them there, they are very, very good debaters. So you could use simple random sampling. Now we have stratified sampling. This is when population is divided into subgroups, stratas. They're divided into subgroups, then the sample taken from each of them. So, for example, sampling students from each grade level. I want to make an analysis of, okay, how good are the students in this school? How are they really taking them well? Are they teaching them well? So all of a sudden, I just went to grade five and I just say, okay, I'm going to take all their check all their scores, and and from there, I got to understand that these grade five students, oh my god, their scores and their it's quite very very low. But from that aspect, I've been biased because I want to use that to determine the qualification of that school, of how they teach and how they are very good at what they do. So now it's now expected of me to now find a way to get my data. And how do I get that sample data? I need to do it in a way that it is very, very not it is very, very equal and not biased. So I can use stratified sampling to say, okay, I'm going to take some students from each of the grades, the levels that we have in the school, and I do my sample. So when you talk about stratified sampling, it's a population that is divided into subgroup stratas, then sample is taken from each. So sampling students from each grade levels in a school would now help me to be able to, like, okay, grade five, from grade one to grade five, oh yeah, come outside, and I'm picking all, like, few people from them, and I'm like, okay, I want 10 from each of them. And I've got what I need to sample. Then we have another type of sampling called cluster sampling. This is when the population is divided into clusters, and then the entire clusters are randomly selected. So you are randomly selecting an entire classroom to survey in a school. So now this classroom, you're saying, okay, I want to just select these people, and I'm like, okay, I'm going to pick randomly for me to do what, to survey. So if I pick if I select the entire classroom now, I can easily say, oh, this is what I want to do with these people in this class, from this class, and I'm getting what I need to do from there. So when you're talking about cluster sampling, this is when population is divided into what, clusters, and then the entire clusters, when you've divided them into clusters, the entire clusters are not what, randomly selected. Then we also have systematical sampling. This is selecting every nth member of a population after a random start. So, for example, you are surveying every tenth customer entering a store. You want to go and ask a question about their satisfaction to whatever they are purchasing from a store, and that store actually, like, they have different branches in the whole of the country. So let's say 10 to 15 branches, and then you feel like, oh, what if I ask the 10th person or the 10th customer entering each of these stores for me to do what, get what I need to analyze and do what. So systematical sampling is just telling us that you are selecting every nth member of the population after a random start. Moving on, representative sampling, which is what we're talking about. We're talking about a sample. That's what we were talking about, which is also the same as saying representative sampling, because, yeah, you have a whole target of population, and then you need to pick samples, which is representing the population. That's what we mean. So, what is the importance? So, from what I'm talking about in terms of sampling and population, we said a sample that accurately reflect the characteristics of the population. That's what we're talking about, representative sample. So if you can see from this diagram here, I have a target population, and you can see the colors. Then if the ones that are unrepresented are unrepresentative, you're seeing the sample there. And while we see the sample here now, you see it's not looking so good because it's like I just chose randomly. I just went there. But then this is representative. You can see each color. I have them here, and they are representing the population, the target population I have, each of them. So why does it matter? Validity, number one, it ensures findings can be generalized to the whole population. Number two, accuracy, it reduces the margin of error in results. Yes, cost effective, allow for studying large population without surveying everybody. Because, yeah, to get, I think I used to remember, I used to hear about when they are doing census of a country, and I used to hear that it's quite very very expensive, because in order for them, in this uh our country, let me just stop there. So it's very very expensive to try to say you want to get the whole population to do what you want to do, but you could easily just try to get access to just a sample that would be able to help you do the study of what you want to do on a larger population. Time efficiency, it enable quicker data collection and analysis. Key point: a representative sample is crucial for drawing reliable conclusion. For drawing reliable conclusion. Moving on, we have the common bias in data collection. So, like I said, sometimes when we are trying to collect data, yeah, we need to understand that some things need to be checked or looked out for, which is in terms of biasness. Talking about number one, selection bias. This is when the sample does not represent the population correct, accurately. So, if you could look at that representative sample I just did now, it's just literally more of the selection bias. From what we have here, this unrepresentative sample is quite biased because in terms of selection, I have my target population already. So why can't I just represent just one person come to represent them there? Then picking this now makes it what? Selection bias. And so example, only surveying people who visit a website, specific website when you want to survey people that are visiting a particular or visiting the internet or something, so you're just going to a particular a specific website, being biased in terms of selection. Then we have response bias. This is when respondents answer question inaccurately or untruthfully. Yes, we have that. You need to put that into consideration too. Example, giving socially desirable answers in a face-to-face interview. Yes, that happens a lot because you're trying to do interview and like, we're recording, you're recording care. That kind of thing. You want to make people, that kind of thing. But you need to look into and consider that kind of bias. Then we have volunteer bias. This is when sample consists only of people willing to participate. What are the people that are not willing to participate? Do you know why they are not participating? So all of these things have to be looked and put into consideration. So when you're sampling, we are only surveying people who choose to fill out an online questionnaire. But because of this, let me just go to places that I know that they will fill. What if those people that are even going to fill are not going to be giving you what you need in terms of what they are going to fill? So sometimes these are the common bias we need to look out for. Survivorship bias. This is focusing only on people or things that have survived a particular process. So you want to study only successful businesses to understand success factor. Why only successful businesses? Why not unsuccessful businesses too? So all these things need to be put into consideration before you say you want to, understand something and all like that. Mitigating biasness. How do you mitigate biasness? So if you look at my diagram here, it's tips for mitigating implicit biasness. So B, which is be mindful of blind spots. I, individuate strangers. A, acknowledge assumption. S, steps, side steps and stereotypes. So when you're, mitigating biasness, you need to use random sampling method when possible. Ensure anonymity in surveys to encourage honest response. Use multiple data collection methods. Be aware of potential bias and account for them in analysis. Very important. And regularly review and refine data collection process, which are very, very important for us to mitigate biasness. Conclusion. Proper data collection and sampling are fundamentals to reliable statistical analysis. So understanding different sampling techniques help us in choosing the most appropriate method. Always try for representative sample to ensure a valid conclusion and be aware of potential bias. Take steps to mitigate them too. And I would say that's the end of our class. While I, want take questions, I'd say this class might end soon, I guess. But then we can still take our question. And if you have any question, please let's just ask now. And this slide has been sent to the group where we can always get to look through it and also make further research about what we've spoken today to have understanding about it. Like I said, it's just introduction to statistics. In our next class, we'll be looking at type of statistics where we have the descriptive statistics, inferential statistics. We'll start looking at what are those status things that we use to describe what are the type of models, what are the types, talk about central tendencies, talk about so yeah, more to come. But then let's get to study more on what we've learned today. So, any question? Yeah. Before that, I think I have an exercise, and I would just quickly want us to look at it. And this is the exercise. So, I would want somebody to just quickly, if anybody can give us 1 to 5 answers to categorize this data set. So, what data type do any one of them fall into? So, we have Yeah, let's start now. Anybody? Student name, the grade level, the age, favorite color, tech score, number of siblings, height. Anybody want to give us a category? The type, like data type. What data type do they fall into? Okay, so if we have nobody to help us out with that, um, I think I okay. Amit ends in okay. Somebody has a question. Amit ends in 3 minutes. Okay, so this is the solution to that. With student name, talk about nominal, the grade level, ordinal, the age, ratio, the favorite color, nominal, text score, interval, number of siblings, discrete, height, continuous, and assignment. Study the slide. So please, your question can come in, and please let's get to know that if, as I'm answering the question, and is the meet ends, I would try to send or text the answer of the question you asked. So I don't think I need to start creating another link for the class. And our next class is going to be on Thursday, same time, and get to dive deep into statistics more. So please, your question can come in now. Okay, I thought somebody had a question. Okay, if there's none, okay, yeah, you can ask, please, because the meet will end soon. Like we just have like a few minutes, so I'm considering not to just create another link because we've literally covered what we want to cover. Okay, I hope we all signed in for the attendance, and I think we'll just thank you very much, and meet again next class on Thursday. Class, the meet is ending now. So on Thursday, the link will be shared again, and we'll get to learn more about um, statistics.